For our final video in our series looking at how ions form, we're going to take a look at neon as an example of a family of elements that do not form ions at all. Now, even if we don't recognize where neon is on the periodic table, we can still look at its valence shell, which we can see has 2, 4, 6, 8 valence electrons. Now, if you remember anything from our previous video on ions, this number should be rather interesting, as in the second and third shells, this indicates that a valence shell is full. Again, if it is the second shell or the third shell of electrons. Now, if this is full, and if neon already has 8 electrons, we can conclude that neon does not need to gain electrons because it already has 8, nor does it need to lose electrons because, again, it already has 8. It has the maximum number of electrons that the second shell can hold. Now, this means that neon is relatively unique among elements in that it doesn't form ions at all. Although, if we assume that neon was an isolated case, we would be wrong, because if we look at where neon falls on the periodic table, we can see that neon is in group 8, and therefore it isn't just neon, but all elements within neon's group that have a full set of 8 valence electrons. Now, if you remember from the video where we learned about the different element families, you would recognize this group of elements as what we call the noble gases, and the distinct feature, as we can see from the group number, is that their valence shells are already full. Now, does this include helium, even though helium only has 2 valence electrons? Well, the answer would be yes, because if helium only has 2 valence electrons, that would mean that its first shell is full, and therefore it does not need to lose or gain electrons at all. And therefore, helium, as well as all of the elements below it, neon, argon, krypton, xenon, and radon, do not form ions at all, because once again, their valence shell is already full. Now, there is actually a second group of elements, or rather mainly 2 elements of note that we can take a look at that also do not form ions, although for a very different reason. And the most well-known of these elements is actually carbon. So if we take a look at the number of valence electrons that carbon has, we can see that carbon actually only has 4. Now, in this case, if we do the question about whether it is easier for carbon to lose electrons or gain electrons to have a full shell, we run into an interesting problem. Carbon would need to lose 4 electrons if it forms a positive ion the way that metals do, but carbon would also need to gain 4 electrons if it were to form an anion as nonmetals do. Now, this is because 4 is exactly half of 8 valence electrons, the maximum number of electrons that can be held in the second or third shells. And the interesting feature here, because it is just as easy for carbon to gain electrons or lose electrons, the answer to which is easier is actually neither. So this is a unique feature of elements carbon and silicon that have valence shells that are exactly half full, meaning that losing electrons and gaining electrons is exactly as easy or as difficult to do. So that means that they actually do neither. Instead, as we will see when we look at a special category of compounds that aren't made up of ions at all, carbon and silicon, because their valence shells are half full, actually have or form a full outer shell by sharing electrons with other elements that they form compounds with, and therefore do not form ions at all, because once again, it is equally easy or equally difficult for it to lose or gain, and therefore both of these 2 elements opt for a solution that is kind of halfway in between. Now, this concludes our series on how nonmetals and metals form ions. To see whether you truly grasp this information, we leave you with this final question here, that being taking a look at hydrogen. So hydrogen is interesting among elements because it is basically the only element that naturally forms positive and negative ions. So see if you can use your knowledge of how ions form, both in terms of metals and nonmetals, and even looking at certain elements that don't form ions at all, and see if you can use your knowledge of ion formation to explain why hydrogen is equally able to form a positive ion and a negative ion, and join us in the next series of videos where we look at what happens when we put multiple atoms together in order to form compounds.